Assalamu alaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today is a part 2 of a lecture series about atmosphere, and in this particular lecture we will discuss different layers of the atmosphere that are present in the structure of atmosphere. The atmosphere of the earth is a vast expanse of gases involving our entire earth. Within this envelope, we are surviving and all our activities are confined. It is made up of several gases, water vapor, and minute particles suspended in the gaseous substance of air. The atmosphere extends several hundred kilometers above the Earth's surface. It is not uniform at every height, and as we climb above in the atmosphere, it has very drastic changes with height. The change is very sharp, but within a layer, the changes are slow. In this particular lecture, we will discuss about the structure of the atmosphere. Apart from that, our concern will also be to throw light on the importance and utility of the atmosphere for us as well as for the entire living system. So the first layer of the atmosphere, which extends from 0 to 10 kilometer, is the troposphere. The word tropos is the Greek word which means turn. Actually, and sphere is means a ball or a structure which is round in shape. So the troposphere is a three-dimensional object with turning or mixing characteristics. Every sort of living life is confined to the biosphere, which include land, water, and air. The upper limit of the troposphere, which is called as the is called the tropopause, and it is the transition zone towards the stratosphere. So the troposphere is the lowest and densest layer of the atmosphere. It extends till a height of like about 10 kilometer, and about 80% of the total mass of the atmosphere lays in this layer. With increase in height, the temperature keeps on declining, and why this temperature is declining, there are many reasons. The one reason is that we are moving away from the earth's surface. So earth's surface is hot, but as we move up in the atmosphere, the temperature further decreases, because we are moving away from the earth's surface, which is the container of the solar heat. Next, as we move upward, the density of the air decreases. Density of air decreases means the number of particles or the gases which are storing the heat of sun are decreasing. So when those number of particles are decreasing with the height, so the result is that overall temperature of the troposphere decreases. One other major characteristic of troposphere is the water vapor, which is found in this layer, and about 99% of the total atmospheric water vapor is concentrated here in this layer. However, there is a variation in this water level, and the water plays or the water vapors plays a very important role in regulating the temperature of the earth by creating greenhouse effect. Then there comes the second layer of the atmosphere, which is called as stratosphere, and it starts from the tropopause to approximately 50 kilometer above in the height. The temperature at the tropopause remains constant until the height of 20 kilometer. After that, it starts increasing and continue till the height of about like 50 kilometer. So why this temperature has been increased, and the only reason of increase in temperature is due to the presence of ozone layer. So as we are showing here that this layer majorly contains the ozone molecules. In stratosphere, actually there is no atmospheric turbulence. The layer is completely free from clouds, and also the all other weather phenomena are occurring in the troposphere. There is no weather changes in the stratosphere. So that is why this is advantage for flying long distance supersonic jets, that there is no air turbulence or weather conditions, so they try to fly in the stratospheric layer. 90% of the ozone molecules are concentrated from like 15 kilometer to 50 kilometer in the layer of stratosphere, and the upper layer of the stratosphere is also called as stratopause, which is very narrow strip, and then this is the transition zone into the mesosphere. Stratosphere is also called as ozonosphere due to the presence of ozone molecules. The ozone layer is very important. It protects the living world from the harmful effects of the ultraviolet radiation. However, this layer of ozone is depleting day by day due to the excretion of chemicals or the release of chemicals into the atmosphere. The chemicals include like chlorofluorocarbons or hydrofluorocarbons. We will see the ozone formation and its depletion in the next lectures. However, as this is the ozone is the main carrier of solar UV radiation and it filters, so that is why the temperature is in rise in the stratosphere. This slide actually describes the variation of ozone. So again we have explained it with the help of a graph. On y-axis is the attitude in kilometers, whereas on x-axis is the ozone concentration. So if we see here that there is a slight increase in ozone concentration at the level of troposphere. So this ozone is called as tropospheric ozone, whereas the major ozone is present in the stratosphere, which is called as stratospheric ozone. So there are two types of ozone: tropospheric ozone and stratospheric ozone. Tropospheric ozone is also called as bad ozone and it is about of 0.15 ppm, whereas stratospheric ozone is called as good ozone and it is about 15 parts per million in concentration. Why this ozone ground is called as bad ozone? This is actually close to the earth boundary, so that is why it is also called as ground level ozone. It is bad because it has been created due to the human activities or anthropogenic activities, and it cause secondary pollutants and it cause products that are very dangerous to health. So that is why this ozone is called as bad ozone, whereas the ozone which is present in the stratosphere, it is called as good ozone, as it filters UV radiations that are coming from the sun. So if this layer is not present, then all these UV radiations from the sun will reach the earth and it may cause the diseases like skin cancer, etc. So that is why this layer is the protective layer. But this same ozone molecule that is present in the stratosphere, in the troposphere, is dangerous to health because it produces so much products, especially during the smoke days, which are very dangerous and cancerous to human health. The next layer of the atmosphere is called as mesosphere. It is the third layer and it is the uppermost layer of the homosphere. After this layer, the hetosphere starts and it extends normally from 50 to about 85 kilometers on the Earth's surface. The air pressure is very low in this layer, and this layer is characterized by a continuous decrease in the temperature, and about coldest temperatures of the atmosphere are lying in this layer, and about 100 to 130 centigrade in minus are the coldest temperatures that are recorded in these layers of the atmosphere. The role of air pressure is very important in order to describe the temperature of the atmosphere. So as we move upward in the atmosphere, so we see here that the air pressure is continuously decreasing, and like this is the graph which showing the attitude on y-axis and air pressure on x-axis in terms of Pascal. So here we are seeing that as we move upward, so the air pressure is decreasing continuously. So at a height of about 32 kilometer, 99% of the air lie below this altitude, and above there is no air molecules. So this description has been given in this diagram. So there are lot of air molecules or the constituents of the atmospheric gases, but as we move upward there are no air molecules or no gases are present. So as these molecules carry the solar radiation heat, so as we are moving upward these molecules are decreasing in number, so it means the heat carrying capacity of the molecules is also decreased, and overall temperature of that region also decreases. So in this way, the decrease in air pressure describes the variation in the temperature as we move upward in the atmosphere. Then this is the fourth layer, which is called as thermosphere, and it extends from like 85 kilometer well above 120, and sometimes about 650 kilometer in the temperature on this layer also rises, and there are small oxygen molecules that are present in this layer which store the solar heat and increase the temperature. Sometimes the temperature of this layer may reach like about 1200 centigrade. However, this much high temperature is primarily defined by average speed with which molecules are moving. Because of this, the temperature may be high. However, the effectiveness of this temperature is not that great. Its exposure to astronaut, if they are coming out from the capsule, is not affecting at all, because there is no movement of molecules because of the absence of the air currents or wind. So although there are molecules and they store solar heat, but we don't feel so much high temperatures due to the absence of movement in those molecules, because conditions are stagnant here. So that is why, although the temperature may seems very high, but it don't feels so much high, and the astronauts and the that are coming from the outer space station, they can very well survive in this region of the thermosphere. A very important phenomena occurs, and this phenomena is also called as aurora, and it is a conspicuous phenomena observed in the layer of thermosphere. It is actually a striking display of light and are maximum between 10 p.m. to 2 a.m. in the magnetic polar region of the northern and southern hemisphere. The northern aurora is also called as the aurora borealis, whereas the southern aurora is also called as aurora australis. They are referred as the northern and southern lights. Actually, the charged particles coming from the solar flare reaches the Earth's upper atmosphere. These charged particles collide with nitrogen and oxygen molecules present in these layers. The collision results into a little surges of light. This scattering of this light seen is very beautiful and magnificent, and this is called as northern and southern auroras. So all these phenomena is actually happening in the thermosphere part of the atmosphere. So this is the overall structure of the Earth's atmosphere, and in this structure of the Earth we have discussed various layers of the atmosphere. Then we have discussed why there is the variation in different temperature ranges, and then we have discussed why some layers are included in homosphere while others are included in heterosphere. So this was all about today's lecture. I hope you have well understood this lecture, but if you have confusion, let me know in the comment section. I will respond to your queries as soon as possible. Okay, thank you. Allah Hafiz.